Welcome back, classes. Thanks for tuning in. I know we're kind of in strange times right now. I'm going to try kind of a different format here where I just want to be a little more personable, a little more connection instead of just seeing my iPad and, seeing my or hearing my voice a little bit. This is just a little bit better interaction. If you like this, just let me know. It's just one of those things I want to try. I have the technology available, so I know it's kind of weird. You're in my home, you're in my spare bedroom. You even see my dog here, but it's one of those things. I think it's just better connection a little bit. You can see me instead of just hearing my voice the whole time. Basically, what we're going to do is we're going to jump right in and kind of talk about the topics for this week. We're in week 3, part 3, where we're doing the Google form, going through the answers here, and we're still talking about the Pythagorean Theorem. So I just want to kind of go through a couple problems here that I gave you on the Google form. If you didn't try that, you can go try out. You don't have to do them all. Again, they're voluntary. It's just I just want to give you some opportunities to do some. Didn't know if the last couple weeks, if, I gave you enough problems, maybe it was just like too easy. But I did throw a lot at you. Apologies. It was just one of those things I wanted to give you kind of a plethora of problems. But let's kind of go through. We'll jump right in here, and we'll get away from seeing my face because you don't want to see that. So we'll jump right into the iPad and we'll. All right, so the first problem that we have here is where we're finding x. Now this is a right triangle. On this particular triangle, this is your A. Whoa, that's a terrible A. This is your A, this is B, and this is C. Now, how I know that? C is always the hypotenuse, it's always across from the right angle, and A and B are the two walls that touch the 90. That's how I know it. So when we do the Pythagorean theorem, a squared plus b squared equals c squared, by just looking at the picture, you should be able to instantly tell where A, B, and C should be, because there should be no question about where they're at. All right, so plugging these in, again, I don't care which one's A and B, that's why I kind of erased it there. I'm just going to put X as my A, that's what I labeled earlier, and then the 24 is B, and we have to square that. And then the 74 is going to be my C. And I'm going to square each of those. So I have X squared, and now 24 squared, I think that's 576. 24 times 24, 576. And 74 times 74, that's 5,476. So again, it's one of those things I want you to kind of try out some problems where you're trying to Pythagorean theorem out a little bit. Now we're solving for x in this case, so I'm going to subtract the 576 across. So let me transition to the calculator here just so you can see this. All right, so I'm going to take the 5,476 and I'm going to subtract the 576. All right, so we're getting 4,900. Now, from that, now what we're going to do is we're going to take the square root. Now, on most calculators, the square root key kind of looks like this. I know mine has the little index numbers. That's little like numbers off to the side. Square root has a little 2. And sometimes they kind of pre-print it there, so that's a little index number. And that's what I'm going to hit here. And it tells me my answer is 70. Now, the reason why we're doing that, if I jump back to the iPad here, is because we're taking the square root of 4,900, which is the answer we're looking for. That number goes here. That's the 70, and that makes that triangle a right triangle. All right, let's jump right into the next one. We'll kind of fly through these next few. So here's what we have. We have a squared plus b squared equals c squared. Now, how I know that this is the case in this particular problem is because that my a and b have to touch the 90. This is my a and b in this particular problem. So 21 squared, that's going to be 441. And 35 squared, that's 1225. All right, we're going to subtract that over. Again, I'm not going to jump back to my calculator here. I'll just do it for you. 1,225. We're going to subtract the 441, and we're getting 784. And then we're going to take the square root because that's the opposite of a square. So we take the square root. So I hit the little square root key on my calculator for 784, and it gives me 28. And there's the number that we're looking for. Again, it's one of those things that when you first see it, you just have to like see one or two of them and you kind of get the flow for how they work. The biggest thing that most people make mistakes on is not knowing which one's A, B, and C. So just C is the hypotenuse, it's the wall across the 90, it's the only wall that doesn't touch 90, so that's how I know kind of where to put the numbers in. But again, you have to square them. All right, let's jump into the next one here. So next one we have a squared plus b squared equals c squared. Oop, that's a 66, not a 62. 66 squared. All right. Going through this, so 33 squared, if I type that in my calculator, that's 1,089. And the 66 squared, that's the 4,356. And then we're going to subtract this number over. So 4,356, we're going to divide by, or subtract over 1,089, and I get 3,267, and then take the square root of them. So if I take the square root of that, so the square root of 3,267, I'm getting 57.16 if I round it, and that's the number we're looking at. Again, just knowing where A and B is, again, I don't care if you had A and B switched, it doesn't really matter. You know, x squared isn't always going to be A, or, you know, it's kind of wherever you put it. You have to know which one needs to be A and B. So C is the only wall that has to be by itself on the Pythagorean Theorem. All right, let's jump into the next one. I'll get rid of my face here, and we'll jump right into the next one. All right, this one in particular, it's an isosceles triangle. If you saw one of the examples I provided you earlier, they're moving this 16, they're separating it over both halves. As you can see here, it's split equally. So this would be 8 and 8. That's what those little marker means. They're the same size. So you have to take the 16 split in half. So this is actually the triangle that we're working with. We're finding x here. This is 15. This is the right angle. And then this is 8. If I just kind of rotated, if I just turned it a little bit so you can see that. So in this particular case, a squared plus b squared is equal to c squared. On this case, the x is the hypotenuse, so that has to be the wall by itself. It's the only wall that doesn't touch 90. A and b have to be the walls that touch 90. So 15 squared is 225, and 8 squared is 64. I'm going to add those two together, so you should get, what, 289? And if we take the square root of that, I think the square root of 289, I think it's 17, if I'm not mistaken. I think it's perfectly 17. Let me type it in my calculator. Square root of 289, yeah, 17. So it's kind of making sense here, hopefully. All right, let's go to the next one. So we have A and B are 12 and the 16, so I have to square each of those. How I know those are A and B, they touch the 90. And then my hypotenuse is the C on this particular case, and that's x. 12 squared is, what is that, 144. 16 squared, I believe that is, what, 256? 16 times 16, 256. All right, I'm going to add those two together. So 256 plus 144 is that perfectly 400. And then we're going to take the square root of that, square root of 400. And that should be a nice 20. 20 times 20 is 400. Again, if it turns out to be decimal, so be it. All right, going on to the next one. Now, this is one that I know that we needed to kind of look at. It's one of those problems. It's one of those problems that when you see it, it can definitely throw you off. It's got fractions in it. So I know that we didn't get a lot of practice with this, maybe in class, but it's a nice one to kind of see every once in a while. So 4 over 9, 4/9, we're going to square that, plus the x squared. Those are my A and B, and that's going to equal the hypotenuse squared, so 8/9 squared. Now when you square these fractions, you have to actually square both. You have to square the top and the bottom. So the square of the top, that's 16 over, what, 81, that's 9 squared, x squared. And then on the other side, 8 squared is 64, and 9 squared is 81 again. So I know it's kind of weird that we had to take power 2 to both. And then now I'm going to subtract this over. When you subtract fractions, you have to make sure they have the same denominator, which in this case, the brilliant part about this problem is that they had the same denominator, so I can subtract it. If all else fails, then you have to change that. So I can actually do this. So 64 minus 16, you get 48 over 81. And then you have to take the square root of that. 48 over 81. Now, if you actually want to know how to type that in a calculator, you have to actually take the 48 divided by 81 first if you want like a decimal of it. So 48 divided by 81, you get 0.59. In fact, let me just transition to the calculator here. All right, so let's clear that out. 48 divided by 81. I'm getting 0.59, and then I'm going to take the square root of that number, so 0.76. So this is roughly, if I go back to my calculator here, or go back to my iPad, I should say. Took the square root of that, that's 0.769, and that's the number we're kind of looking at. Now, if you want to leave the exact answer, just leave the radical. All right, let's move on to the next one here. So this one, kind of same old, x and 4 are my a and b. Don't care which one's which. And then the 16 is my hypotenuse. So 4 squared is 16. My 16 squared is 256. I'm going to subtract this over, so I get 240. And then take the square root of that. Now the square root of 240 is not a clean number. My calculator here and just kind of show you that. The square root of 240, so if I type in 240, I have to type in the number first, then hit the square root key. It's 15.449, and that's the number we're kind of looking at. Again, this is an approximation. It's not an exact number, so hopefully that makes sense. All right, let's jump to the next one here. We've got a few left. So a and b, that's a and b are the x and the 72. And 78 is the hypotenuse. That's my c in this case. Let's jump right in here. Solve this one out. So we have x squared, 72 squared. If I type that number, that's 5,184. 78 squared, 6,084. I'm going to subtract that 5,184 number over. So 5,184, subtract that over, I get 900. And then take the square root of that. Square root of 900 is a perfect 30. 30 times 30 is 900. That's what square roots are. All right, let's jump right back in here. Another one with fractions. So again, we just got to identify where a and b are. So a and b are the 3/5. Square that, and the 1/5. Square that. And the hypotenuse is x in this case. Now, when we square them, we square the top and the bottom. Square the top and the bottom. 1 squared is 1. And we add those two together, so we get 10 over 25. And now I just got to take the square root of that. Now, this is the exact answer for this particular problem. But if I actually want to find the decimal, take 10 divided by 25 on a calculator, which is 0.4, and then take the square root of that. So square root of 0.4 should be 0.02. Nope, not even close. 0.6324. So there you go. But again, it's one of those things, like once you get into these, like it's not really that difficult. You just kind of get through the motions of it. Kind of an easier problem here for you. 2 squared plus x squared equals 5 squared. All right, so we have 4 plus x squared equals, what is that, 25? We subtract this over, I get 21. Oh, it's not letting me write that 1 there. Okay, and then I take the square root of that. 21. So square root of 21, what is that? Square root of 21, 4.58. Okay, so there you go. Let's jump into the next one here. All right, so this is kind of a goofy one. It's got kind of numbers and variables everywhere. If you can see it, this is the right triangle that's in question. This is the thing we're really kind of focused on. So if you can't see that, my a and b are here and here, and then this is the c in this case. So 9 squared plus 12 squared is equal to x squared. That's kind of the setup for that. I get 81 plus 144 equals x squared. If I add 81 and 144, I'm getting 225, which actually has a nice perfect square root. Square root of 225 is a nice 15. That's nice, 15 times 15. Okay, we only got a few problems left here. So the next one, we have the 14 squared plus 48 squared. Ooh. Apologies, iPad turned off in the middle of recording that. We're kind of in the middle of this one. So 48 squared plus 14 squared equals x squared. Again, 48 and 14 are your A and B. 48 squared is 2,304, and 14 squared should be 196. So 14 times 14. All right, yep, 196. And now we're going to be adding those two together. So 2,304 plus 196 should be 2,500. And taking the square root of that. So square root of 2,500 should be a nice 50. Yeah. Again, the goal is to figure out where A and B and C are, plug them into the Pythagorean Theorem in the right locations, and then just solve. And you're always going to take a square root in the end. Now, it's not going to work out to be a nice pretty number every time, like you've seen some of the other ones I've done. But sometimes, the ones that, I've picked out, usually they kind of work out to be a nice clean number. Let's kind of go on. We only got about 4 problems left here, 5 problems left. So we have 5 squared plus x squared equals 13 squared. 5 squared is 25, and then x squared, and then 13 squared is 169. It's 13 times 13. I'm going to subtract this across, so subtract the 25 across, so I get, what is that, 144? If I subtract 25 across, and that has a nice clean square root, which should be a nice perfect 12. So again, working out nice and pretty on some of these. Next one, we have 9 squared plus x squared. Those are my A and B. They touch the 90-degree marker. And then my hypotenuse should be the 15. We have to square that. 9 squared is 81. 9 times 9. 15 times 15 is 225. We're going to subtract the 81 across. So 225 minus 81 is a perfect 144. And we just did that one a little bit ago. Square root of 144. Ooh. Wow, that is not allowing me to write that 4. 144. There we go. Wow, it would not let me write that. There was a 12. Okay, let's jump to the next one. So we have 8 squared plus 12 squared is equal to x squared. Again, my A and B are the two walls that touch the 90. So 8 squared is 64. 12 squared is a 144. I'm going to add these two together. So we're going to get a 208, I believe. 144 plus 64. 208. And that is not a clean number, so I take the square root of that. Square root of 208. And I'll transition to my calculator here just so you can see that. Alright, let's clear out the last one we just did. Alright, so 208. So I might have to type in the number first. So 208, and then I'm going to hit the square root key. So I'm getting 14.4. Let's transition back. Here. So 14.4, and that'd be the number for my hypotenuse. That makes sense. It's the biggest side of that triangle. Okay, 2 problems left. We have 16 squared plus 30 squared is equal to x squared. Again, the x happens to be the hypotenuse on this one. So 16 squared is, what is that, 256? 16 times 16. And 30 times 30 is 900. All right, so we're going to add the 900 plus the 256, and I'm getting 1,156. And then I have to take the square root of that. And again, if you just type that in your calculator, 1,156, take the square root, I'm getting a nice clean 34. So there you go. And the last problem on that Google form. This one's kind of a tough one to see, but this is the triangle that we're dealing with right here. We do have my A and B. This is my A and this is my B in this particular problem. This would happen to be my C, the 14 would be. So it would be x squared plus 10 squared is equal to 14 squared. So I get 196 on the other side. I get 100 over here. I'm going to subtract the 100 across, get 96, and then take the square root of that. Now the square root of 96 is really close to 10. It's 9 point something. But 96, taking the square root of that, square root of 96, 9.79. So there you go. Just wanted to say thank you for all those who are actively participating. Again, this is, totally optional. It's just one of those things. I want to provide you a little bit of, not not really new material, but just review of stuff that you've previously done. So hopefully it will clean some stuff up in the future. In the next couple weeks, I'm going to start to try to introduce some new material, but I'm going to do it very, very slowly. This might be a time like when you need help, email me, text me, call me. I'm going to try to set up some Google Meets, maybe in the next couple weeks, where if you really need to check in and maybe you're really struggling in a certain material, you can. But I'm hoping that you're staying healthy, that you're taking care of yourself and your family. I know it's kind of a weird time. If you like the format that I'm doing here, where I'm trying to be a little more personal, where you can see me instead of just hearing my voice the whole time, I'll continue to do that. I got some different options. I got a lot of technology here, so I can try out. But it's one of those things that just, the priority here is to, to worry about, your own health, but also I still want to continue your education the best I can. So, again, hopefully you're finding yourself, some time to relax and you're not getting overwhelmed by all these activities we've been doing. But again, take care of yourself, and I'll see you next time.